Hi folks, this is Calc 2 Quiz 6. Number 1, we're asked to write the first 4 terms of the sequence defined recursively by this set of equations. And then we're asked if the sequence converges. So A1 we're given as 3. And now I look at this recursion equation, and I'm going to substitute n equals 1. That's the first n this is valid for. If I substitute n equals 1, I get a sub 2 equals 5 minus a sub 1. Well, a sub 1 is given to be 3. 5 minus 3 is 2. So a sub 2 is 2. A sub 3. If I substitute 2 into this recursion equation, I get a sub 3 equals 5 minus a sub 2. A sub 2 is 2. 5 minus 2 is 3. And finally, a sub 4, when I substitute 3 into this recursion equation, I get a sub 4 equals 5 minus a sub 3. A sub 3 is 3, so I get 5 minus 3, which is 2 again. And so the sequence is 3, 2, 3, 2, etc. So those are the first 4 terms of the sequence, and you can see that it alternates between 3 and 2. So does this sequence converge? Well, the limit as n goes to infinity of a sub n does not exist, since it alternates between 3 and 2. So half the terms are always 3, half the terms are always 2. These numbers never settle down and get close to any one particular number, and so that means it diverges, it does not converge. And so that'll do it for number 1. All right, number 2, we're asked to find the limit of this sequence. And many of you use L'Hopital's rule on this. Certainly it is in the form infinity over negative infinity. The problem with using L'Hopital's rule is that this is a function, a discrete function of n. N is a natural number. In order to employ L'Hopital's rule, we need to have a function of a real variable x. So if you're determined to use L'Hopital's rule on this, then I would ask that you change this into the limit of a function of a real variable. Then you can send it to the hospital as much as you want and get that. All right, so I'm a stickler about this. In order to use L'Hopital's rule, you need to be able to take derivatives. You can't take derivatives of functions of natural numbers. You need to take derivatives of function of real variables. So if you're going to use L'Hopital's rule, pass it to the limit of a function of a continuous variable. All right. Now, you don't actually need L'Hopital's rule at all on this. You can actually get at this limit by just using good old-fashioned arithmetic. You factor out the highest power of n in the numerator and the denominator. That cancels out. We get the limit as n goes to infinity of 3 over 1 over n squared minus 4. As n goes to infinity, this quantity goes to 0, and I'm left with negative 3/4. All right, so no matter how you do it, the answer is negative 3/4. And that'll do it for number 2. Okay, the last one on the quiz, we're asked to prove this sequence is non-increasing and bounded below. To show it's non-increasing, we have to show that the a sub n plus 1 is less than or equal to the a sub n. And so what we're going to do is substitute n plus 1 in for the n. And the question is that going to be less than or equal to the a sub n? And so what we do is we're going to do some reversible algebra steps, and hopefully we'll get to a conclusion that's always true. So I think the best way to handle these kinds of inequalities is remember that everything in sight is positive, so we can multiply and divide by anything we want. I like to get the things that look the same on the same side. So to that end, I'm going to take the n plus 1 factorial here over the n factorial, and I'm going to take the 4 to the n over here underneath the 4 to the n plus 1. So by multiplying and dividing both sides by 4 to the n and n plus 1 factorial, I get that. Simplifying, I get that. And then by rewriting this inequality, I get this. Now if you notice, this is exactly the condition we're given. The n is greater than or equal to 3. So if n is greater than or equal to 3, I can reverse all of these algebra steps to get back to an plus 1 less than or equal to an. So this shows that the an is non-increasing. Now, bounded below means we need to find a number that all of these terms are bigger than or equal to. Well, 4 to the n is always bigger than 0, and n factorial is always bigger than 0. That means 4 to the n over n factorial is always bigger than 0, which means the sequence an is bounded below by 0. And what's important about having a non-increasing sequence bounded below? We're guaranteed then that this thing is going to converge. And so that'll do it for quiz 6.